Alright, so let's take a look at this binomial theorem question. Part A, write down the number of terms of this expansion. Okay, so we have this binomial being raised to the 16th power. So remember, the number of terms of the expansion is always going to be 1 greater than whatever the power is. So if the exponent is 16, that means this expansion is going to have 17 terms. Okay. Part B, find the coefficient of x to the 20th power. All right, so let's set this up. So we've gonna set this up. So if the exponent is 16, we know 16 goes here. This would be our binomial coefficient that we calculate later. Over here, this is the x to the third, and then this is going to be 2 over x. I'm going to write it without the fraction bar, so I'll write it as 2x to the negative 1 power. Okay? So now the next step is we need to figure out what exponents go for these factors here. Okay? And we need to try and get x to the 20th, end up with x to the 20th, right? So for example, let's say I put 5 here, right? Well, then this over here would have to be 11, because remember, these two exponents always have to add up to whatever this value is right here, right? So this would give me x to the 3 times 5 is 15th. Over here, this would give me x to the negative 11th. But if I simplify this, this is going to leave me with x to the 4th, right? But we're trying to get x to the 20th. So we know 5 and 11 is not the right combination of exponents for these two factors. So you kind of have to play around a little bit, kind of maybe do a little guess and check. But if you use some good educated guessing, you'll be able to find out what these two exponents should be. Okay? So for example, let's say I try 9 and 7. So 3 times 9, that's x to the 27th. Over here, this will give me x to the negative 7. So when I simplify this later, that gives me x to the 20th, which is what I want, right? So we know that 9 and 7 are the correct values for these two exponents here for these factors. Okay, so it might take you a little bit of time to find what the correct exponents should be, but it shouldn't take you too long. Right? Now once you've found these two exponents, now remember, you could choose either one of these numbers to put here. So it doesn't matter if you put 9 here or 7, because when you calculate this binomial coefficient, it's going to give you the same answer anyway. Okay, so it doesn't matter if you put 9 or 7 in this case, just pick one of these exponents and put it on the bottom here. So I'll just put 7. Okay, all right, so next thing, we're gonna basically have everything set up. We're gonna calculate all this. So this is a GDC problem, right? We're allowed to use the calculator. So let's calculate our binomial coefficient with the calculator. So let's say with your TI Inspire, you would just go to menu, probability, combinations, and we're calculating 16, choose 7. So just put a 16, comma 7, comma 7, and we end up with, all right, 11,440, all right? And just to show you that it actually doesn't matter which values you put there. Now remember our other option, right? We could have put, instead of 7, we could have put a 9 right there, right? So if I actually do 16, choose 9, you notice we get the same result, right? So that's why it doesn't really matter. Once you find these two exponents here, it doesn't matter which one you put down here, because when you calculate that binomial coefficient, it's going to give you the same result, okay? So we had 11,000, I believe, 440. That was our result from the calculator, correct? And then let's calculate the rest of it. So this will give you x to the 27th. Over here, don't forget to do 2 to the 7th power, right? So a lot of students sometimes they forget you also need to raise 2 to the 7th power. So 2 to the 7th power, just in case you need to calculate that, we can calculate that. 2 to the 7th, 2 exponent 7. That'll give us 128, right? So we've got 128 x to the negative 7. So if we simplify all this, right? So basically we're multiplying, all right? 11,440 times 128, so 11,440 times 128, we end up with 14,64320, right? So we've got 14,64320 x to the 20th. So our coefficient of x to the 20th is, looks like 1,464,320. Okay? That would be your answer. Alright, so let's take a look at this binomial theorem question. Okay? In the expansion, we have x squared multiplying with this binomial raised to the 6th power. It says the coefficient of the term x to the 4th is 6,000. Right? So if you simplify all this, so the coefficient of x to the 4th would be 6,000. So we would have 6,000 x to the 4th. Right? So it's asking us to find the values of k. So now let's think through this problem. So we have this x squared here on the outside. And it's multiplying with this binomial being raised to the 6th power. Right? Now this binomial here, if we were to actually expand this out, basically what would happen is, let's think about it, we would have a bunch of terms, right? We would have a bunch of terms, and so you have to think, x squared times something, right, has to give you x to the 4th. So from this expansion, we're looking for the term, right, that has the x squared, because when you multiply these together, right, x squared times x squared, that would give you x to the 4th, okay? So what that means is, from this binomial right here, right, when we calculate this, we want the term that has the x squared, right? We want the term that has the x squared, okay? So now that we know that, let's set everything up. So I've got this x squared on the outside. I'm going to leave it in the outside for now. So this, all right, binomial right here, I'm going to set up the binomial coefficient over here, which is going to have a 6. We don't know what's going to be on the bottom yet. And then our factors are kx to the 3rd and 2x to the -1. Right? So I'm going to write that so that is not a fraction. Now we need to find the combination that's going to give us x squared. So we need all of this right here to end up with some number with x squared, right? Because we're going to multiply this with this x squared on the outside, and then that'll get us x to the 4th. Okay, so that's basically the methodology, the idea behind this question. So now that we've got this set up, so we need to end up with x squared. So once again, you just play around with the possible combinations of exponents, and you want the one that's going to give you x squared, right? So let's say we have 2 here and 4. Well, x to the 3rd to the 2nd power would give me x to the 6th. This would give me x to the -4th. So you notice here, this would give me x to the 2nd power, which is what I want. So that means the 2 and the 4 right here is the right combination of exponents for these two factors. Okay? So you could pick 2 or 4, put it down here, it doesn't matter. Let's say I put 4. And then let's calculate this right here. Okay? Let's go to the calculator. 6 choose 4. So we've got 6 choose 4. Menu, probability, combinations. Just put 6, 4. That gives us 15. So this is going to give us 15. K to the 2nd power, so don't forget that. We need to have k to the 2nd power. So raise k to the 2nd power, x to the 6th. Over here, 2 to the 4th power is 16, x to the -4. So if you work all this out, you're going to end up with basically 15 times 16. So 15 times 16, 15 times 16, 240. We end up with 240 k squared, and x to the 6th and x to the -4th will leave you with x squared, right? And this is exactly what we want. So this gives us something with x squared, because now we're going to multiply this x squared on the outside to this, and then that gives us 240 k squared, right? Sorry, not k, yeah, k squared, and then x to the 4th. And then this is going to equal, and now remember they said if we expanded this out and multiplied everything, the x to the 4th is going to have a coefficient of 6,000 x to the 4th. So this is going to equal 6,000 x to the 4th, right there, okay? And then now we need to solve for k. Well, the x to the 4th, they divide each other out right there. So that's gone, divide by 240, so k squared is equal to 6,000 divided by 240. So 6,000 divided by 240, that gives us 25. square root both sides, so k is going to equal plus or minus 5. And that would be your answer. Okay? All right, so let's take a look at this next binomial theorem question. So this one's a non-GDC question, right? So you can't use a calculator for this one. So this question says we have 2x plus 1 raised to the n power, and it says the coefficient of the term x squared is 540n, right? So basically what that means is 540 times n would be the coefficient of x squared if we were to expand this out, right? And we need to find the value of n, and they say n is a positive integer, okay? So let's set everything up. So we've got our, let's start with the 3 parentheses. Our exponent is n, so just put n there. We don't know what that is. We're going to find that. And then we have 2x, and we have 1, okay? Now, since we're trying to get the x squared term, you know that this exponent has to be a 2. It cannot be anything else, okay? So if this is a 2, then this exponent has to be n minus 2, because if we add these two together, it should equal n, right? It has to equal this value here. So now that you've got these two exponents, remember you could choose either one of these to put down here. So anytime you have a number versus like a variable with a number, I would recommend putting just the number. So it'd be better to put the 2 here instead of n minus 2, because then it's just easier to do that calculation later by hand, okay? So I would just put the 2 here. I would recommend putting the 2, even though you can also put n minus 2 and still get the same correct answer later on. All right. So now we need to calculate this binomial coefficient by hand since we cannot use a calculator. So let's set this up. So this means n factorial divided by 2 factorial times n minus 2 factorial. So what this is going to give us, right? So n factorial means n times n minus 1 times n minus 2 and so on, right? On the bottom we have 2 factorial, which is 2 times 1 times n factorial. So n factorial is n minus 2, and then we would have like n minus 3 and so on. So basically what happens is all these would divide each other out, so that's gone. So what we're left over with is n times n minus 1 divided by 2, right? So when we calculate this binomial coefficient here, we get n times n minus 1 divided by 2, okay? And then let's simplify the rest of this. So times, we get 4x squared. And don't let this fool you. So 1 to any power is still going to be 1. So it doesn't matter what this exponent is. So this here is still going to be 1, right? And we know that this is going to equal, right, 540 times n x squared. And then we need to continue simplifying this, okay? So let's continue simplifying this. So the first thing I'm going to do is, so I know the 2 and the 4, I can reduce these. Since everything is being multiplied with each other, I can reduce the 2 and this 4 right here, right? So basically I have 2x squared n, right? Actually, I'll just distribute this n first. So I get n squared minus n, right? Times, this would be 2x squared. So I'll just move the 2x squared to the front. And then 1 is just, this will keep this the same thing. Is equal to 540 nx squared, right? So first of all, I can divide now by the 2x squared, right? If I divide by 2x squared on both sides, so this would divide this out, so I would be left over with n squared minus n is equal to, that would give me, I believe, 270. The x squareds divide each other out, n, right? So then now you want to set it equal to 0, n squared minus 271n is equal to 0. And then let's continue working this out. We're going to take out the GCF, which is n. So we have n parentheses n minus 271 is equal to 0. So n will equal 0, and n will equal 271. Right? Now earlier, remember, I said n has to be a positive integer. So we know we're going to reject the 0. Right? So our answer is going to be 271. Okay? All right, so let's take a look at this binomial theorem problem. Right? So this is similar to the last one a little bit. So we have 3x minus 1 raised to the 2n power. And it says the coefficient of x squared is 18 times 2n minus 1. So 18 times 2n minus 1, this is the coefficient of x squared, right? So we need to find out what n is, and n is a positive integer, right? So let's set up the problem. So this is going to be our binomial coefficient. We have 3x is the first factor, the second factor is -1, right? So we have a 2n here because that's the exponent here. Now since we're trying to get x to the second power, this has to be a 2, right? Because that's the only way we'll end up with x to the second power. Over here, so that means this would be 2n minus 2, because if you add these two exponents, it should give us this, okay? Now you have the choice between putting a 2 down here or a 2n minus 2. I would just put the one that's a number, right? That would make it easier for us to calculate this binomial coefficient later, right? So now let's calculate this binomial coefficient. We have 2n factorial divided by 2 factorial times 2n minus 2 factorial, okay? So let's expand this out. So this is 2n, right? Then it'll be 2n minus 1, then it'll be 2n minus 2, and so on. Down here we have 2 factorial, which is 2 times 1, and then 2n minus 2 factorial would be 2n minus 2, and then it would continue on, right? So these divide each other out. Over here, the 2's, they divide each other out. So basically we end up with n times 2n minus 1, right? So we have n times 2n minus 1, right, when we calculate this binomial coefficient. And then we have times 9x squared, right? Now -1, so let's think about this. If you have 2n minus 2, right, that means that it doesn't matter what n is, this exponent here will always be an even number. If this exponent here is always an even number, regardless of what n might be, that means that -1 to some even power is always going to be a +1, right? So this will be +1, okay? And we know that this is going to equal 18 times 2n minus 1 to the x squared, right? So let's simplify everything. So first of all, if I divide by 9x squared on both sides, now since all of this is multiplying, I divide by 9x squared on both sides. So this will divide each other out. So the 9 and the 18, that divides out. The x squares divide each other out. So we end up with just 2n squared minus n is equal to, and over here we distribute the 2, so that would give us 4n minus 2, okay? And then let's set the problem equal to 0. So we have 2n squared minus 4n on both sides. This will be minus 5n, and then plus 2 is equal to 0. And then let's factor this. So we end up with, this would be 2n and n minus minus, leave it 2 and a 1. So -4, -1 is -5. That gives us +2, so we factored correctly. So it looks like n will equal 1 over 2. N will equal 2. Now remember, it said that n is a positive integer. Okay. Now 1 over 2 is not an integer; that's a rational number. So we're going to reject the 1 over 2. So you know the correct value for n is 2. Okay. All right, so let's take a look at this binomial theorem question. So we have kx squared times this binomial expansion, right, is going to give us the term, right, x squared with a coefficient of 3,919,104, okay? So 3,919,104 x squared, okay? So if you think about it, what's happening is this already has x squared. We need to end up with x squared, right? So that means that we want this expansion from here, we want to find the value that has no x's, right? Because if you already have an x squared outside here, you have to multiply by just the constant, right? Because if you multiply by anything with an x, then you're going to get a higher exponent, right? Like x to the third, x to the fourth, and so on. So what that means is we need to find the term from this expansion that has no x's. Okay? So when we set this up, we have kx squared on the outside here. And then this expansion here, we're trying to find the term where the x's will cancel each other out. So this is going to be a 10. We've got 3x. This is kx to the negative 1. So it doesn't turn out these exponents are going to be 5 and 5, because what happens, we would get x to the 5th and x to the negative 5th, which cancels each other out. You would have no more x's for this term, which is what we want, right? So let's simplify the rest of the problem. So this would be a 5 down here. So 10 choose 5. We could use our calculator to calculate that. It's a GDC question. Menu, probability, combinations. All right, 10 comma 5. We get 252. Okay, 252. So this gives us 252. 3 to the 5th power. I believe that gives us 243. X to the 5th. And then, don't forget to raise k to the 5th power as well, right? That's a common mistake. And we have x to the negative 5th, right? So we have all this multiplying with the, right, kx squared. So you see what happens here. These x's are going to cancel each other out. So we're left over with only the x squared, which is what we want, because we only want x squared, right? That's why it was important for all these x's to cancel each other out here. So now we're going to multiply everything. So 252 times 243, 252 times 243. That gives us 61,236. So 61,236, right? We would have x squared, and then we also have the k to the 6. Is equal to 3919104 x squared. So the x squares obviously divide each other out. So we're going to end up with k to the 6 is equal to, we're going to take this value, 3,919,3919104 divided by 61236. So let's divide that. Let's see what that gives us. Oops. 3,919,104 divided by 61236. We end up with 64, right? So k to the 6 is equal to 64, so that means k is going to equal plus or minus 2, right?